Hi, good day and welcome to video 62, and today I'm going to show you guys how to do an histogram. So let's jump right into it. So here we have a chart, right, a table, and for some reason we're given the task of measuring the length of straws. So I guess that we're working in a straw factory, and I just want to show you how to interpret the table here. First of all, these things in the middle here are not minus signs. The length of straws. So how frequency is the amount of times something happens. So to give you an idea, how many straws were between 11 to 20 centimeters? And that answer would be 27 straws. So that means for some reason when we were in the straw factory, 27 of the straws, when we measured them, had a length between 11 to 20 centimeters. So 11 to 20 means 12, 13, 14, 15, all the way up to 20. And 5 straws had a length of between 71 and 80 centimeters. So how do you draw an histogram? Well, the first step is, and a lot of people don't know this, is that to all the numbers on this side of the lengths, we're supposed to add a certain number. And all the numbers on this side, we're supposed to minus a certain number. What is that certain number we're supposed to add or subtract? All we have to do is take these two numbers, always in this direction. This one should be, well, most of the times bigger than this number. So the 11 and the 10, what you need to do is always minus those two numbers. So in today's question, here's 11 and here's 10. Never minus the other way. It's always this way. Minus the two numbers, and you always, no matter what, divide by 2. So today, well, 11 minus 10 is 1. 1 divided by 2 is a half, better known as 0.5. Now, in most exams, when you minus these two numbers and you divide by 2, most of the times you will get 0.5. And if you're at the point right now where you did a lot of past papers, you're going to realize that probably around 99% of the questions, when you minus them, you're going to get 0.5. It will not always be 0.5. You might be the unlucky person to get a question where when you minus them and divide it by 2, you do not get 0.5. So the point I'm trying to make here is don't always assume it's 0.5, because a lot of students will just start the question and they won't even do the calculation. They will just start automatically adding 0.5 to everybody on this side and minusing 0.5 from everybody on the other side. Don't get tricked easily like that. Make sure and do your calculation and make sure it's 0.5. Great. So let's get started here. So all the numbers on this side, you're going to add 0.5. So 10 plus 0.5 is 10.5, then 20.5. Well, I'm guessing that you get the gist right now. So you're adding 0.5 to everyone on this side. Now, notice that when you add the 0.5 on this side, obviously the numbers get bigger by 0.5. These new numbers, you call them your upper class boundary, or UCB, upper class boundary. Now, don't forget we have to minus 0.5 to all the numbers on the other side. So 0 minus 0.5 is minus 0.5. 11 minus 0.5 is 10.5. 21 minus 0.5 is 20.5. And well, we keep going. You notice that this number matches up with this number. This number matches up with this number, right? So it shouldn't be too hard to see the pattern. And of course, 70.5. Right. So all the numbers on this side got smaller by 0.5. And what do you think the appropriate name for this would be? It would be the LCB, or lower class boundary. So the first step, the first real step in a histogram is to identify or calculate your upper class boundary and to calculate your lower class boundary. Remember, this side is the add and the other side is the minus. Now, the next thing we have to get correct is our scale before we start to draw anything on the diagram. in the examiner should mention somewhere in the question what the scale should be. Now, in my last video, we went through some scales, and I know that I kind of rushed through it, and not everyone would have picked up on everything. So I'm going to use this opportunity to do a quick revision. Over here, according to this question, the x-axis, which is your horizontal, every 1 centimeter is going to be 5 units. And on the y-axis, every 2 centimeters is going to be 5 units. Now let's identify what type of graph paper we have. Do we have today the T-Rex or do we have the Lego? You notice in this one it has the smaller blocks, so that would be the Lego graph paper. Remember, in the Lego graph paper, every small block, well, so not every block that you're seeing, every dark line is actually 1 centimeter. So from here all the way here is 1 centimeter. Right, so let's get started here. Now it's gonna take, you have to be super neat when you're doing a histogram, so you gotta be a little patient in this video. So every 1 centimeter is going to be 5 units. Now I have two options here. Every from here to here is 5, that's 1 centimeter, so it's equivalent to 5 units. So if from here to here is 5, that means from here to here, 2 blocks later will be 10. Now if I write 5, 10, 15, 20, 25, 30, it's going to look very cluttered. I would instead prefer, if here is 0, 2 blocks later, let's call it 10. Now this is the same scale. I'm not changing the scale. It's from here to here is still 5. So that means 1 centimeter is still 5 units. I'm just choosing this method so the graph paper doesn't look cluttered. So that means every 2 blocks is going to be 10. So here will be 30. Here will be 40, 50, 60, 70, 80, 90. Sorry, well, there's some writing over here. Right, so that went off screen a little bit there. 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. Right. So on the y-axis now, every 2 centimeters is equal to 5 units. Remember, from here to here is 1 centimeter. So from here to here would be 2 centimeters, and that 2 centimeters need to be equal to 5. So here's 5. 2 blocks down the road, 2 centimeters later will be 10. No, that's wrong. That tells me 15. Right, so give me 15, 20. Just give me a little chance here. 25, 30, 35, 40. If you get bored, you can just pass forward the video. 35, 40, 45, 50, 55, and the last one on top is 60. Now I know I could have written this before the video and just pop it into the screen, but I think if I did it this way and you actually see me label it, it would have made you would have understood it better. So that's why I chose this route. Okay, so let's begin to let's identify the worth of every small block. Remember, I told you it was super important to figure out how much each small block is worth. Let's do the x-axis. On the x-axis, we are counting in. On the x-axis, we are counting in tens. So we are counting in tens according to this. I know from here to here is 5, but from here to here is 10. Now that's too small. That's 2 blocks. Sorry. So that means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small blocks within here. We always take what we are counting in and divided by how much small blocks we have. We have 10 small blocks. So 10 divided by 10 is 1. So that means every small block here is worth 1. So if here is 20, the next actual small block is 21. So every small block is 1 on the x-axis. That's for the x-axis. For the y-axis, if you notice, we are counting in 5s. 0, 5, 10. So from here to here is 5, so we are counting in 5s. And from here to here is 2 blocks, and if you notice, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small blocks. So we are counting in fives, and we have 10 small blocks. So 5 divided by 10 is 0.5. So every small block on the y-axis is worth 0.5, which means if here is 15, the next small block, the line over here is 15.5, making the next one 16, then 16.5. In other words, every 2 small blocks is 1, meaning that if here is 25, the next small block is not 26, you know. If here is 25, then 2 small blocks above will be 26. So here will be 26. And next 2 blocks will be 27. Because in one of them we are counting in tens, and one of them we are counting in fives. So our mindset has to change between here and here. So let's begin plotting, well, drawing the histogram now. Right, so this is going to take a little while. I have my ruler here. All right. So the first block usually starts, this goes on the x. Whatever we are measuring goes on the x. And your frequency always goes on your y. So x and y. We're going to get a series of rectangles. So our first block starts at minus 0.5 on our x. Now if you notice, we do not have a negative 0.5. So we're just going to choose the next best thing, 0. And it starts at 0 and ends where? At 10.5. Now remember what 10.5 is. 10.5 is in between 10 and 11. If here's 10, the next small block is 11. So for me to get 10.5, I have to go in between the 10 and 11. So I need to make sure I have a very sharpened pencil. And how high does it have to go? It has to go 10 high. So let me draw this for you. So that's my first rectangle. I'm going to try to bring it closer to you guys here. If you notice, this line here is in between the 10 and 11. It's not on 10 and it's not on 11. It's exactly in between. And how high do we have to go? Well, we have to go exactly 10 high today. So we're going 10. So that's my first block. We're finished with this block here. On to the next block. 10.5, 20.5. Now, the next block starts off where the other one finished. So here's 10.5. I don't have to look for it. It's already for me here. And it's going to end at where? 20.5. Remember, 20.5 will be in between 20 and 21. A lot of students have the habit of saying once they see a 0.5, they jump to the middle of the 2 measurements and say here's 20.5. But that would be completely wrong. Because if here's 20, and remember on the x-axis we're counting in 1. So if here's 20, here's 21, 22, 23, 24, 25. Here's 25. We are looking for 20.5. If here's 20, over here's 21. 20.5 will be in between the 20 and the 21. And how high does that have to go? It has to go 27 high. Remember, if here's 25, on the y-axis, if here's 25, here's 25.5, 26, 26.5, 27. So don't make the mistake and think on the y-axis, every small block is 1. It's actually 0.5. So that means I had to go 4 blocks above the 25 to reach 27. And, well, we have to make little buildings next to each other here. All right. Let's bring this a little bit closer here. All right. See? All right. Hoping that you can see it a little bit better there. All right. So let's do the rest of the blocks quickly. Now that we understand, I think we understand the scale a little bit better here. So let's go to the next one. The next one, we're finished with this guy. Let's go to 20.5 to 30.5. 30.5 will be in between the 30 and the 31. So, and how high does that have to go? 33. Where would 33 be? 33 would be 6 blocks above 30, because if he has 30, every 2 blocks is 1. So if he has 30, 2 blocks above is 31, and next to is 32, and our next to will be 33. Right? If you notice, it looks like buildings stacked up next to each other. And this building touches the other building. And where this building finishes, the other one will start. Do not go back all the way here and draw a big building. This building will touch where this one finished. Right? So we're finished with this guy here. Let's do 30.5. Sorry. Let's do the 30.5, 40.5. 40.5 is in between 40 and 41. And how high do we have to go? 55. Let's go. 55 will be, oh, well, 55 is right here. We have a line called 55, so we don't need to look too hard for that one. So 55 is here. It's one of the actual dark lines. Oh, this is going to take a while, guys. I need to have a good eye for these things. Right. All right, so let's do the next one quickly. Next one is 40.5, 50.5, and how high it is? 41. 50.5 is in between 50 and 51, so that's somewhere here. And how high do we have to go? 41. Where would 41 be? It would be 2 blocks above 40, because every small block is 0.5. 40.5, 41. Alright, let's go. Wish I had a long ruler. Can't find my long ruler today. Someone's always stealing my long ruler. Alright. Now I try my best to go in between the small lines. Alright. The next one, we're almost there, is 50.5, 70.5. Now, I put this one aside here for Spike because I wanted you to see something. If it was 70, the next one is 71, so 70.5 is in the middle. And how high do we have to go? 18. If here is 15, 2 blocks above will be 16, and next 2 blocks 17, and our next 2 blocks 18. Let's see what's so special about this one here. You notice that how this block is fatter than the other blocks? That's perfectly okay. In a histogram, one of the blocks could be fatter than all the other blocks, right? So don't get too worried in the exam if one block is a little bit thicker than the other block. So let's do the last one quickly. And this one is 71.5, where the last one finished, and it's going to 80.5. And how high is it going? 5. This one should be easy, right? A good idea is to be doing this question with me as I do the video, right? Just watching me doing it doesn't do justice. You actually have to get involved in the question. All right, so we just drew our histogram. Now this is worth a bunch of marks in the exam, right? And the scale is what you need to be so concerned and well focused on. When you're counting in tens, it's completely different as if you're counting in fives. Let's quickly find this thing called your mode. Your mode is supposed to be the most popular. To find the mode in a histogram, you just look for the tallest block. It shouldn't be too hard. Well, he's the tallest block. He's the tallest out of all of them. The tallest block will be adjacent to 2 shorter blocks. You notice that this one on this side touches it over here. So this block touches the taller block. I'll call that point A. And the block on this side touches the taller block at point B. So what we're going to do, I should probably use a different color. where A is, you're going to draw a funny looking X. From A, you're going to go up to this corner of the tallest building. And over here, where B touches the taller building, you're going to draw a line from here to the other side of the taller building. You will not get a perfect looking X. It'll be a funny looking X. Notice the X meets over here. Wherever they meet, drop a straight line downwards. And the number it falls on is the mode. So let's see what's the mode for my question. Well, let's drop it straight down. And it seems to me, if here's 31, 32, 33, 34, 35, 36, it dropped somewhere on 36. So that means the mode of, well, the mode for the length of straws for this particular question was 36, right? So that's the modal length, 36 centimeters, okay? So I really hope that you enjoyed this video and you understood everything in this video. And of course, just keep reminding yourself over and over and over. Whenever you have a scale, reason out the worth of every small block before you start plotting your points. All right, so in my next video, I'll be showing you all how to plot a cumulative frequency curve, right? And I'm going to use the different the other type of graph paper. I won't be using the Lego. I'll be using the T-Rex graph paper. So for those of you who have the T-Rex graph paper, well, hopefully it will help you out a lot, right? But don't get accustomed to one type of graph paper. Get both types of graph paper. And sometimes when you have one question, use the Lego graph paper. And in other questions, use the T-Rex graph paper. Because in the exam, you don't know what kind of graph paper they're going to provide for you. All right, so take care. Have a good day.